A white dome on the stern of a US destroyer slews hard to port. Inside it, a 6-barreled 20mm Gatling gun spins up. Within a second, it is firing at 4,500 rounds per minute, 75 shells every single second, a solid column of depleted uranium and tungsten punching through the Gulf air toward a target the size of a motorcycle. The target costs roughly $2,000. The ship carrying that gun cost just over $2 billion, and the target is still flying. That is the problem. Not a failure of engineering, not a failure of nerve. A problem of pure geometry, and it is the geometry that Pete Hegseth's Pentagon and the commanders of the 5th Fleet have been studying with increasing urgency every time an URG drone lifts off the Iranian coast. Here is what most people get wrong about close-in weapon systems. The Phalanx CIWS is not supposed to be the first answer. It is supposed to be the last answer. The answer you reach for when every missile has already flown, every layer above it has already failed, and the threat is now closest enough to smell. The question worth spending the next 24 minutes on is why that last answer, automated, radar-guided, brutally fast, can still be beaten by something a university student could assemble in a garage. Stay with that question, because by the end of this, you will understand exactly where the gap is, why it exists, who is deliberately exploiting it, and what the crew of a destroyer in the Strait of Hormuz actually has to decide in the 4 seconds before the geometry closes for good. To understand why the Phalanx struggles with the Shahed Wen 30C6, you have to understand what it was built to fight. When Raytheon delivered the first production units to the US Navy in 1978, the primary concern was the Soviet anti-ship missile, fast, heavy, radar-emitting, flying in from range on a predictable ballistic arc, the SSN-2 Styx. Later the P-700 Granite, missiles doing Mach 0.9 to Mach 2.5, big radar cross-sections, clear engagement geometry. A fast target closing at speed gives the Phalanx something to work with. The radar can track it, the fire control computer can lead it, and the burst of 20mm shells can be placed where the target will be, rather than where it is. The Shahed 136 flies at roughly 180 km per hour. That is slower than most commercial drones used for aerial photography. It has a radar cross-section somewhere between a large bird and a small aircraft. Small enough that in a cluttered littoral environment, full of fishing boats and commercial traffic and sea spray reflections, it can sit in the noise floor of a ship's radar for far longer than anyone is. Comfortable admitting, and it flies low, sea skimming in some profiles below 10 meters above the waterline, using the surface clutter to mask its approach until it is already inside the engagement envelope that was designed for something much faster and much louder. Donald Trump's administration has been public about the pressure on naval air defense in the Gulf. Through late 2025 and into 2026, the posture has been one of deterrence and layered defense. SM-6 interceptors for the outer ring, evolved Sea Sparrow missiles for the middle ring, Phalanx as the terminal layer. The theory is sound, the practice runs into arithmetic. The SM-6 is a remarkable weapon. Active radar homing, range out to around 400 kilometers in its latest variants, capable of engaging ballistic missiles in their terminal phase, cruise missiles, low-flying drones. It costs approximately $4.1 million per round. The Shahed 136 costs somewhere between $20,000 and $50,000, depending on the production run and the components sourced. The Iranian defense industry has been optimizing the supply chain since sanctions forced them to domesticate more of it. Against a target at $30 million a copy, that math is already uncomfortable. Against a target at $20,000, it is close to absurd. But here is the part that does not make the press releases. The SM-6 is not always the right tool for the job. At very short range, against a very slow, low-flying target in a cluttered environment, the SM-6 has minimum engagement parameters that can work against it. The missile needs time to arm, to acquire, to maneuver. A drone that is already inside 2 to 3 kilometers when it is detected may simply not leave enough geometry for the SM-6 to solve the problem, which is exactly where the Phalanx is supposed to pick up the thread. The Phalanx engagement envelope opens at roughly 1.5 to 2 kilometers. That sounds like a long distance. Against something flying at 180 kilometers per hour, 2 kilometers closes in approximately 40 seconds. 40 seconds sounds like enough time. It is not, once you factor in what actually has to happen in those 40 seconds. First, the ANVP's 2 search radar has to detect the target. In a clean sky over open ocean against a large, fast missile, this is straightforward. Against a slow, low, small drone with a minimal radar signature, threading through surfaces returns, this step alone can consume 15 to 20 seconds of that 40-second window, sometimes more. The Phalanx operates in an autonomous mode. Block 1B, the current version, can search, track, engage, and assess without human input. which is operationally necessary because humans cannot process and act within this timeline. But autonomous engagement of a low, slow, small target over a busy waterway creates its own set of problems that we will come to. Second, once the radar locks, the fire control computer must calculate a firing solution. The Phalanx uses a closed-loop miss distance system. It fires a burst, watches where the rounds go relative to the target, and corrects. This is elegant and effective. Against a fast missile, it works well because the geometry is consistent. Against a target making erratic course changes, or against a target so slow that the gun's own lead calculations are outside normal parameters, the system has to iterate. Iteration takes time. Third, the gun fires. At 4,500 rounds per minute, the M61A1 Vulcan cannon empties a magazine of approximately 1,550 rounds in about 20 seconds of sustained fire. That is not 20 seconds of continuous trigger pull. The system fires in bursts, typically 1 to 2 second bursts, to manage barrel heat and allow the tracking radar to assess whether the target is still flying. A standard engagement might use 2 to 4 bursts. Each burst at full rate delivers 75 to 150 rounds. Now hold those numbers and introduce the variable that changes everything. Not one drone, many drones. The USC did not develop the Shahed 136 as a precision strike weapon in the traditional sense. They developed it as part of a saturation doctrine. The strategic concept, which USS Carney and USS Carney commanders have been refining since at least 2019, is built around one observation. Any point defense system, no matter how capable, has a finite magazine and a finite engagement rate. If you can generate more valid targets, then the system can service within its engagement window. Some targets will reach the objective. The question is never whether every drone gets through. The question is whether enough get through. And that calculation looks very different depending on which side of it you are on. A US destroyer running a standard Phalanx Block 1B has one CIWS mount, sometimes two on larger platforms. Each mount carries roughly 1,550 rounds. In a sustained saturation engagement against multiple simultaneous targets, that magazine can be depleted in under 2 minutes of active firing. The Phalanx has no rapid reload at sea. Once the magazine is empty, it is empty. The ship then relies entirely on whatever missiles remain in the Mk-41 vertical launch cells, SM-6, SM, whatever the specific loadout holds. Here is a number worth sitting with. A standard Arleigh Burke-class destroyer like the USS Hasty carries 96 Mk-41 vertical launch cells. Not all of those are loaded with interceptors. Some carry Tomahawk land attack missiles. Some carry anti-submarine rocket rounds. A reasonable combat load might include 32 SM-6 rounds and 32 SM rounds. Against an USC saturation attack using Shahed 136 drones in waves of 20, 30 or 40, the math compresses very quickly. Even at a 95% intercept rate, a number that would represent extraordinary performance in a contested electronic warfare environment. A wave of 40 drones produces 2 leakers, against a wave of 4 leakers. One Shahed 136 carrying a 45 kilogram warhead, striking an Arleigh Burke amidships, can cause mission kill level damage. The outcome depends on where it hits and what it hits. What is striking about this problem is that it cannot be engineered away with a better version of the existing system. The CIWS magazine depth, the engagement timeline, the radar discrimination problem in a cluttered environment, these are not bugs. They are the physics of the platform. The Shahed 136's designers understood this. The drone did not happen to fall into the gap in terminal air defense. It was designed to live there. To trace how that design philosophy developed, you have to go back further than most discussions of Iranian drone warfare do. The URG's interest in cheap, expendable one-way attack vehicles predates the Shahed 136 by at least 2 decades. The Mohajer series, first flying in the 1980s, was reconnaissance-oriented but established the institutional knowledge base. After the 2006 Lebanon War, in which Hezbollah used Iranian-supplied drones against Israeli naval vessels, including a hit on the INS Hanit that damaged the ship and killed 4 sailors. The URG drew explicit lessons about the vulnerability of surface combatants to small air threats. The INS Hanit engagement is worth a moment because it previews the Phalanx problem almost perfectly. The Hanit had a close-in weapons system. It was not in autonomous mode at the time of the attack because the crew assessed the threat environment as lower than the threshold requiring it. The C-802 anti-ship missile that hit the ship came in low and fast from the Lebanese coast. The SARS, in manual mode with a crew that had not been expecting that specific threat vector at that specific moment, did not engage in time. 1 missile, 1 hit, 4 dead, significant damage to a capable modern warship. The lesson the URGs took was, even the best close-in defense has a human or procedural failure mode. If you can operate inside that failure mode consistently, you have a doctrine. The Shahed 136 is the industrial scale version of that lesson. Slow enough to be almost non-threatening in profile, cheap enough to be expendable in mass, small enough to sit at the edge of radar discrimination, and designed to arrive not alone, but in coordinated groups that force sequential engagements and magazine drawdown. Going through the open sources documentation of Iranian drone production rates, one figure kept coming back. Estimates from Western defense analysts suggest Iran was producing Shahed series drones at a rate of between 1,000 and 3,000 units per month by late 2024, before any negotiated production slowdown. Even at the lower end of that range, the stockpile math creates a saturation capacity that no single surface group can absorb indefinitely. The magazine depth problem is not just about one destroyer's phalanx. It is about the cumulative interceptor expenditure across a carrier strike group or a surface action group over days of sustained operations. Here is the question that mid-watch officers on US destroyers in the 5th Fleet area of operations are actually working with. If you have 32 SM-6 rounds in your cells, and you are facing an initial wave of 20 Shahed 136 drones, do you shoot SN-6s at them, burning $4 to $8 million per intercept on $20,000 targets? Or do you let the Phalanx handle it and preserve your magazine for the ballistic missile or the anti-ship cruise? Missile that may be riding behind the drone wave as the actual strategic payload? This is not a rhetorical question. It is the decision that gets made in real time under electronic warfare with degraded comms in the dark by a tactical action officer who has between 15 and 40 seconds per track to authorize or pass. The doctrine says layer your defenses. The arithmetic says your layers are finite. The UG doctrine says make them choose. Put yourself in that tactical action officer's position for a moment. It is 0300 local time in the Gulf. The INS Y1D radar is showing 12 inbound tracks, low altitude, bearing from the Iranian coast, speeds consistent with Shahed 136. Your SM-6 fire control solution is ready on 6 of them. Your SM is ready on 4. Your Phalanx is in autonomous mode covering the terminal envelope. You have 17 seconds before the first tracks enter Phalanx range. Do you shoot the SM-6s and burn $8 million, knowing there may be a second wave? Or do you hold the SM-6s, let the Phalanx work, and accept that at 90% intercept, you will have 1 or 2 impacts on your ship? What would you have decided at 3 AM with your magazine at 60% and no backup surface combatant within 20 miles? Tell us in the comments. We read everyone. The electronic warfare dimension of this problem does not get enough attention in public discussion, which tends to focus on the kinetic intercept question. But the engagement geometry for the Phalanx is not just about the radar seeing the target and the gun hitting it. It is also about whether the radar is operating in an uncontested electromagnetic environment. The RGC has invested significantly in electronic warfare capabilities since at least 2011, when an RQ-170 Sentinel UAV was brought down over Iranian territory. Iranian sources claim GPS spoofing. US sources have never fully confirmed the mechanism, but the drone landed largely intact in Iranian hands and was reverse engineered extensively. The Command 22 and the Mobin jamming systems have been observed operating in the Gulf region and represent a real, if imperfectly characterized, capability to degrade radar and data link performance. Against a Phalanx in autonomous mode, effective jamming of the search and track radar creates a specific problem. The system may not detect the threat until it is already inside the optimal engagement window, leaving less time for the closed-loop correction sequence to work. Against a Phalanx in manual mode with a human operator in the loop, jamming creates a different problem. The operator is now making a target discrimination decision with degraded sensor data, in seconds, in the dark, over a waterway with commercial traffic. The Block 1B upgrade gave the Phalanx an infrared search and track capability, specifically to address the radar jamming scenario, but IR tracking has its own limitations in the humid, hazy Gulf environment where thermal clutter off the water surface can degrade tracking geometry. Here is the part that does not sit right, even stepping back from it analytically. The Phalanx Block 1B entered service in 1999. The Shahed 136 was operationally deployed in significant numbers by approximately 2021, with mass use documented in Ukraine from September 2022 onward. That is a 2-decade-old terminal defense system against a purpose-designed small attacker, and the gap between them has been openly documented in combat for nearly 4 years. The upgrade path for the Phalanx involves improved software and the integration of additional sensors. But the fundamental architecture, a Gatling gun fed by a fixed magazine, operating against a single target at a time engagement sequence, has not changed. The obstacle is not technical laziness. The constraint is platform integration. Replacing or fundamentally redesigning a ship-mounted CIWS on existing hulls requires dry dock time, structural modification, and integration testing for every system the CIWS connects to. Fire control, power, combat management. On a fleet of 90-plus Arleigh Burke destroyers, each requiring months of work, the timeline to field a meaningfully different terminal defense architecture runs to years, not months. Meanwhile, URG-C drone production rates continue and the unit cost keeps falling. The Laser Weapons System Demonstrator, LAWS, and its successors, including the INS CIWS, have been tested on USS Ponce and subsequently on USS Portland, demonstrating the ability to engage small UAVs at low cost per shot. Directed energy is the long-term answer to the magazine depth problem. A ship with a megawatt-class laser has essentially unlimited shots per magazine as long as the power plant runs. But the transition from demonstrator to deployed fleet weapon is not complete. The engagement ranges of current systems are shorter than the Phalanx, and the atmospheric effects that degrade laser performance, high humidity, salt spray, Gulf haze, are most pronounced in exactly the operating environment where the drone threat is highest. What does this tell us about the current moment? That the gap between the threat and the defense is real, acknowledged, and not yet closed. And that the URG-C's procurement strategy, not just for Shahed 136, but for the broader family of cheap one-way attackers, is calibrated to stay inside that gap for as long as possible. The economic dimension of the saturation doctrine extends well beyond the cost of individual interceptors. When a carrier strike group or a surface action group is committed to defending against drone waves over an extended period, the consumption of SM-6 and SM rounds begins to affect operational availability. The SM-6 production rate in the United States, from Raytheon's production lines in Tucson, is classified but estimated by public defense analysts at somewhere between several hundred and low thousands of rounds per year across all variants. The total inventory held across all platforms and storage facilities is similarly not public. What is public is that the cost of replenishing a destroyer's magazine after a sustained engagement is significant. The lead time for new production is measured in months, and the ability to surge production in a crisis competes with demand from partners and allies drawing on the same industrial base. The Shahed 136 production line is simpler. The airframe is largely fiberglass. The propulsion is a reverse-engineered MD-550 engine, or a locally produced equivalent. The guidance system uses INS with GPS update, and since GPS jamming is a well-understood countermeasure, later variants have incorporated terrain following and celestial navigation updates. Iran's defense industrial base, under sanctions for decades, has become specifically good at producing things that can be built from materials not on the sanctions list and assembled by a workforce that does not require advanced manufacturing precision. The unit cost has been coming down. The production rate has been going up. The gap between what it costs to shoot the drone and what it costs to build the drone has been widening every year. Here is a take that will probably get some pushback. The real strategic failure in this dynamic is not tactical, it is procurement. For 30 years, US naval surface warfare has been optimized around the assumption that the primary threat is a peer adversary, China, Russia, operating sophisticated anti-ship missiles and hypersonic glide vehicles. That assumption drove investment toward SM-6, toward Aegis upgrades, toward the integration of the standard missile family. All of it correct for the threat it was designed to meet. But the IDCHI was not designing to be a peer adversary. The IDCHI was designing to be a problem that peer adversary-oriented procurement structures cannot efficiently solve. And for roughly $20 of drone per $4 million of interceptor, that problem compounds faster than procurement cycles can correct it. The human side of this geometry is easy to abstract away behind the numbers, and it should not be. Every Shahed 136 that leaks past the Phalanx and impacts a vessel is carrying a 45-kilogram warhead. On a steel warship with a crew of between 200 and 350 personnel, the damage is localized, but the consequences are not. The USS Cole lost 17 sailors to a boat bomb in 2000 in Aden. The INS Hanit lost 4 to a C-802 in 2006. The Phalanx and the entire layered defense architecture above it exists precisely because those incidents demonstrated what a single successful impact by a relatively modest warhead can do to crew, morale, and operational availability. The families of the crew of a destroyer on deployment in the Gulf are not thinking about cost-exchange ratios. They are thinking about whether the ship's defenses are adequate. That question does not have a clean answer when the terminal defense layer is a 1970 S-designed Gatling gun with a 20-second magazine in autonomous mode against a target engineered specifically to exploit its limitations. There is also a dimension that affects the Iranian side of this equation. The Irkutsk crews who launch Shahed 136 attacks, the operators, the logisticians, the maintenance personnel at the launch sites on the Iranian coast or at proxy positions in Yemen operated by the Houthis, or in Iraq at Irkutsk-aligned militia facilities, are operating under the reality that US retaliatory strike capability is not symmetric. A US strike on an Irgi drone facility using Tomahawk cruise missiles launched from an Ali Burke at standoff range, or using FC-18 Super Hornets from a carrier air wing, or an extremist using a B-2 Spirit from Diego Garcia, hits a fixed facility with a precision munition and kills a specific capability. The Irgi absorbs that and rebuilds, but the people inside those facilities when the Tomahawks arrive do not rebuild. The asymmetry of cost per shot cuts both ways. It is cheap for Iran to launch Shahed 136 drones and expensive for the US to intercept them, but it is cheap for the US to strike Iranian launch infrastructure and expensive for Iran to replace it. Which is why neither side has an interest in full escalation, and why the drone saturation campaign exists as a tool of calibrated pressure rather than an all-out attempt to sink a carrier strike group. The math on the latter does not work in Iran's favor, regardless of the terminal defense gap. The math on sustained low-intensity drone pressure, eroding interceptor stocks, absorbing US responses, generating insurance and shipping costs, threatening Gulf state oil infrastructure. That math is a different calculation entirely. The most surprising part of how this plays out operationally is not the Phalanx's limitations. It is how those limitations shape the behavior of everyone above the terminal defense layer. The existence of the gap, the knowledge that a saturation attack can expect some leakers even against a fully operational Ali Burke with a block. 1B Phalanx changes how carriers are positioned, how surface action groups are structured, how combat air patrol patterns are allocated, and how much of the Mk41 magazine gets reserved for threat categories other than Shahed 136 drones. The cheap drone does not have to penetrate. It has to be present in sufficient numbers to force those decisions. Every SM6 burned on a Shahed 136 is one fewer SM6 available for the DF-21D. Anti-ship ballistic missile scenario that PARCOM planners in the Pacific spend a great deal of time on. This is the logic of the saturation doctrine. The drone attack that forces the expenditure of $4 million interceptors may itself be the point. Regardless of whether any drone reaches a hull, the Irgi drains the magazine. The replacement cycle takes months. During those months, the defender is less capable. The strategic pressure is continuous. The cost to maintain it is low. One detail that stuck with me in reviewing the open source analysis of Houthi drone and missile attacks on shipping in the Red Sea through 2024 and 2025. Attacks that used Iranian-supplied Shahed series drones and drew USS Carney and other destroyers into repeated defensive engagements. Single reported figure from a senior US Navy official who told the Wall Street Journal in late 2023 that the cost to defend against these attacks was running into the hundreds of millions of dollars in interceptor expenditure. The Houthis, operating from Yemen, with Iranian supply chains that continued despite US and coalition strikes on launch infrastructure, kept generating new attacks. The engagement rate stayed high. The interceptor consumption rate stayed high. The shipping disruption through the Red Sea, which carries roughly 12% of global trade, caused insurance premiums to spike, routing to go around the Cape of Good Hope, and container shipping costs to rise across the board. The Phalanx did its job in most of those engagements. The math of the campaign still favored the side with the cheaper weapon and the longer patience. So where does that leave the geometry of the last ring? The Phalanx is not broken against the threat it was designed for, a fast, high-energy anti-ship missile in the terminal phase. It remains a capable, proven system against the Shahed 136 specifically. The combination of low speed, low radar cross-section, sea-skimming flight profile, and saturation employment creates a set of conditions that compress the engagement window, challenge the tracking geometry, and deplete the magazine faster than a single-point defense can sustain indefinitely. The physics does not lie. The geometry favors the cheap attacker. Donald Trump's administration has increased naval presence in the Gulf and the Red Sea. Ali Khamenei's government, through Ismail Carney's Irgi and the proxy network that Carney commands, has continued to develop and supply the tools of asymmetric saturation. Masoud Pezeshkian's government in Tehran holds the diplomatic channel, and the question of whether negotiation or attrition wins is genuinely open. The crew of a destroyer in the 5th Fleet area of operations, the USS Carney, the USS Gravely, whichever hull is on station, works with what the architecture gives them. Layers of defense, finite magazines, and a terminal gun that fires 75 rounds per second against a drone that costs less than a used car. The line between trusting the Phalanx and reaching out with expensive missiles is not set by Doctrine alone. It is set by the tactical action officers read of the threat, the magazine state, the electronic environment, and the 15 seconds the geometry allows. Every decision leaves a different hole open, and the URG's Procurement Office understands exactly where each of those holes is. Here's the question we keep coming back to. If you were advising the 5th Fleet Commander on where to set that engagement threshold, suspend the SM-6s early and risk running dry against Wave. 2. Or hold them and let the Phalanx take its chances against the first wave. What would you tell them? Comment yes if you reach out early with the expensive interceptors, or if you hold and let the terminal gun work. We read everyone. If you want to understand how the RGC structures those multi-wave attacks, the sequencing, the electronic warfare coordination, the role of the Fateh 110 ballistic missile that sometimes rides behind the Shahed wave as the actual kill shot, that is exactly what we trace in the next one.